Lesson 4-3, scatter plots and lines of fit. So when we're working with scatter plots, we're looking at data, and you're collecting data. One kind of data is bivariate data, which just means you have two variables involved. A bivariate data consists of pairs of values, and these pairs of values are going to be ordered pairs. A scatter plot is a graph of bivariate data that consists of ordered pairs. Your two variables are your x coordinate and your y coordinate. Using a scatter plot can help you see the trend or a general pattern in the data. And these trends can be used to determine the association of the two different variables being compared. The associations describe the form, the direction, or the strength of the relationship between the two variables. The descriptions of associations include linear, nonlinear, positive or negative, and strong or weak. The direction and the strength of a linear association can be measured by the positive or negative correlation. So this closely resembles like slope. So for a positive correlation, you see a pattern of the lines going up from left to right. So as x increases, your y increases. And they're also clustered closer together. Negative correlation means they are going down from left to right. So as x increases, your y decreases. Now, no correlation means they're just scattered points. There's no pattern whatsoever involved. They're not related anyway. Now, understanding the graphs for positive and negative correlations, many of the points form clusters and they show an upward or a downward pattern. The closer the points are to each other, the stronger the correlation. The further spread out they are, the weaker the correlation would be. And then the points outside of a cluster are outliers. So if there's one that's way out compared to all the other ones, that would be an outlier. And usually when you're dealing with data, you don't work with the outlier too often. So example one, the scatter plot displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in the situation. So in the graph here, we can see they're all clustered together. But as you notice, as you go to the left or go to the right, the weight does increase. So they do have an increasing. So this would be more of a positive correlation. And what this means is the taller the player, in general, the heavier they are. So typically, taller people do weigh a little bit more just because they have more body mass. But it's not for every single person. You could be smaller and weigh more than somebody who is taller. In general, the trend is the taller they are, the more they weigh, or at least for the football players on the New Orleans Saints football team. Next, the scatter plot displays the miles of bike lanes within a city in relation to population. Shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in this situation. Now we have two variables, which is population and then miles of bike lanes. We want to know, does the population dictate the number of miles of bike lanes you two have? Now, if you look at the graph carefully, you can see that there really isn't any pattern to it. You have a cluster here, you have a smaller cluster here, and then you got random ones over here. We would say that there is no correlation with this one. Next, the scatter plot displays the number of landline telephones in the United States in 100 millions since 2000. Determine whether the scatter plot shows a positive, negative, or no correlation, and then describe the correlation's meaning in the situation if there is a correlation. Now, if you notice, as you go to the right, as the years increase, the number of landlines have decreased. So we would say that this has a negative correlation. And we would say as time increases, the number of landlines decreases. And that could be for a variety of reasons. If you think more and more people are using cell phones instead of a landline, so you're going to have fewer and fewer landlines being used. Next is talking about lines of fits. So when you have scatter plots, you'd want to find a trend, and you'd have a trend line or a line of best fit used to describe the trend of that data. So how can you use the linear function to model data? First, you need to make a scatter plot. So you collect the data and then you put them on a coordinate plane. On each point of the data and determine whether there's a relationship existing between the data. And then you draw a line, and the line closely follows the trend line. Now it doesn't have to touch every single point. It doesn't even have to touch one of the points. It just has to go along the trend. Usually you're going to see the line of best fit or a line of fit through the middle of the cluster of points. Step 3, you're going to write an equation. And to do that, you need to use 2 points on the line of fit to find the slope of the line and create an equation for the line using the slope and a point on the line. And then step 4, you can use that equation to make predictions. A couple other vocabulary words with scatter plots: linear extrapolation and linear interpolation. Extrapolation means is the use of the linear equation to predict values that are outside of the range of data. So if you think of in this diagram here, extrapolation is outside of the lowest number that you have and outside the upper part. So that's not on the data that you collected. So extrapolation, you're trying to find what it was before your data was collected or after your last data point was collected. Interpolation means it has to be within here. So you're going to use your equation to find a point that maybe it's not in here, but it's in between your lowest and your largest number. For example, the table shows the average cost of a in the years after 2000. An equation to represent the data, and use the equation to predict the cost of a jet boat in 2005 and 2025. So here we see years since 2000. So the year 2000 was 17,663. And then it goes all the way up to year 2013, which would have been 37,618. The table shows the average cost of a boat in the years after 2000. Write and interpret an equation to represent the data. Then use the equation to predict the cost of a boat in 2005 and 2025. So to do this, we're going to make a scatter plot. The independent variable is the number of years since 2000, and the dependent variable is the cost of a jet boat. As the years increase, the cost of a jet boat also increases. The scatter plot shows positive correlation. So all the data points were put in here. Now you could easily go back to the previous slide, you could put these into your calculator to do the scatter plot. And I can show you a little bit later with another example. But these would be your points that you would put in there, and then you would create the scatter plots. You can see the line of fit that they have in there. You notice that it doesn't touch a lot of the points, but it does touch a few of the points there. So once you make the scatter plot and you draw your line, so you draw your line of fit, the line that follows the trend of the data points and passes close to most of the points. Doesn't have to be all of them, but it has to go according to what the shows the point to be. Step 3, we're going to write an equation of line of fit that gets just close to the data points. And we have some points that we're going to use. So 5 and then 25,108. We go back to that 5 and then that would be roughly here. And then another one would be, they gave us 10 and then 32,752. So at that point, so to do this, we're going to find the slopes. We're going to take 32,752 minus 25,108, and we're going to divide that by 10 minus 5 to find the slope. So we have 32,752 minus 25,108. And we get 7,644 all over 5. If you do 7644 divided by 5, you get 1528.8. Now I'm going to change something up a little bit. Since we were not given this point, if I go back to the chart, we were not given what 5 was. So if I go back to here, I'm going to choose 2 because I know that one is actually on the line. So going back to the table, that would be this point here. So I'm going to use that one because I think that would be a little more accurate. So this would be a 2 here. And the other one would be 21,176. So then if I take that, this will give us 11,576. And if I divide that by not 5, but 8, so 11,576 divided by 8 gives us a better number of 1,447. So we'll use that point. So we use 2 and then 21,176. So now we found the slope. Then our next step would be to create the equation of the line. So if I go back here, let's find the equation of this line here. So we're going to use, we can use point slope form because we're given the point and we're given the slope. Or we could do slope intercept form. Let's do slope intercept form. So the slope, the y would be 21,176. I'm going to use that point equaling slope of 1,447 times 2 plus our b. So I do 1447 times 2 gives us 2,894 plus b equals 21,176. Subtract 2894. So 21,176 minus 2894 gives us 18,282 for our b. So our equation would be y equals 1,447x plus 18,282. So y equals 1,447x plus 18,282. Predict the cost of a jet boat in 2005. So in 2005 is 5 years after 2000. So I'm going to put a 5 here. So now if I do 1447 times 5, that gives us 7235 plus 18,282 plus 18,282 gives us an answer of 25,517. Now, based on our graph, if I go back to our graph, 2005 would be right here, halfway between 20, so that would be roughly 25,000 there. Now, step 5 says extrapolate, which means we need to get outside of that time frame of between 2000 and 2013. We're trying to find in 2025. If I take my equation 1447 times x plus 18,282, 2025 is 25 years after 2000. So I'm going to take 1447 times 25, and then I'm going to add 18,282 to that, and we should have y equaling $54,457. That would be what the estimated cost of a jet boat in 2025. Now keep in mind, when you create your equation for a scatter plot, your equation compared to somebody else might be slightly different because it depends on where they drew their line and what points they used. But it should be fairly close to each other. So when I have 54,457, somebody else could get a little over 55,000. And that would be okay because we're just doing an estimated cost based on an estimated equation of a line. Next example, Dante is holding a bake sale as a fundraiser for his school's chemistry club. He starts the sale at 8 a.m. and ends 7 hours later at 3 p.m. The graph tracks the amount of money he has earned after each half hour since beginning the sale. Here's the data point 1 and 48.50 and 6 and 150.25 to write in and interpret an equation to represent the data. Then use the equation to predict the amount of money that Dante would have raised if he stayed until 4 p.m. Round your answer to the nearest penny. So the first thing we need to do is find their slope. So I'm going to do 150.25 minus 48.50. Divide that by 6 minus 1. And we get 5 on the denominator. 150.25 minus 48.50 gives us 101.75. And if I divide that by 5, we get 20.35. So that would be our slope. And then we're going to use that to come up with our equation. I'm going to put it in slope-intercept form, and I'm going to use this point here. So I have 4850 equals 20.35 times 1 plus b. I'm really just subtracting 20.35 on both sides. And I have b equaling 48.50 minus 20.35 gives us 28.15. So our equation would be y equals 20.35x plus 28.15. So then we're going to use that for the amount of money that Dante would have raised if he stayed until 4 p.m. instead of 3 p.m. So that would be 8 hours. So if I were to do y equals 20.35 times 8 and then add 28.15 to it, I would end up with an answer of $190.95. So what would we interpret this being? This 20.35 would be per hour. So $20.35 per hour he earned, and he earned, this is the earnings at the start. So at the start of the bake sale. So he started with $28.15 and then he earned $20.35 for every hour that he worked. And here, just more workspace if you needed more workspace on that one. For that one, I didn't use that one because I used everything on this slide. But moving to our next example, this data showed the amount of milk a baby goat needs by its weight. So here you have your x variable is your weight, and the milk in ounces is our y. So what we need to do with that is we're going to use the data So what we're doing is we created a scatter plot with that one. And very quickly, I'm going to show you how to do that with your calculator, because using your graphing calculator with a scatter plot will make this a lot easier. So the first thing you need to do is hit Stat, go over, we got Edit, so hit Enter, and you want to make sure these are all clear. If you have data in there, just go to L1, hit Clear, and then hit Enter. And your weight would be your L1, so I do 5, Enter, 7, Enter, 10, Enter, 15, Enter, 20, Enter, 25, Enter. I believe we have to go to, we got 30, Enter, 40, Enter, and then 50, Enter. Then we go to L2 and we put our weight in there. So that would be 12, Enter, 16, Enter. So always hit Enter after every number. 28, 32, 40, 48, 64, and then 80. Once we have that, we want to do a line of best fits. We could do stat calculates. We can put it as a linear line. So number 4, if I hit enter, we would have an equation here. It'd be y equals 1.48 plus x plus 4.52. So that would be one way of creating a line on that one. But for now, they told us which points to use on here. So they created the scatter plots. Let me go back to that calculator so you can see how to do the scatter plot on here. So if I were to go back to this y equals, I want to clear this. I need to turn the plot on, turn plot 1 on by hitting enter. Enter, and I want the scatter plot, which is this first one right here. So that one's already in there. I need to make sure that my list 1 and list 2 are marked here. And now if I hit graph, actually not graph, let me hit zoom. And I need to go down to number 9, which is zoom stat, so number 9. And then it puts my points in there, which will match up with what I have here. And then if I were to go to VARs, number 5, statistics, go to EQ, that'll give us our line. That would be our equation of the line that we can use. If I put that in here, so VARs, number 5, over to EQ, enter, it puts that in there. And then if I hit zoom, number 9, it puts our line through there and gives us our equation of the line there, which you saw what I had before. Now going back here, we're going to use the data points that they give us to create the line equation, or the line. So I'm going to do 80 minus 20 divided by 50 minus 10, which will give us 60 over 40 divided by 10, then divide this by 2 halves, and we get 3 halves, which is 1.5, which was close to what we had. We had 1.48. Divided to the nearest tenth would be 1.5. And then we're going to use that in one of these points. I'm going to use this one. So 20 equals 1.5 times 10 plus b. So this would be 15 plus b equals 20. Subtract 15. My equation would be y equals 1.5x plus 5. Now if I use that equation, predict the amount of milk needed for a 17-pound goat. X means the pounds. So if I put y equals 1.5 times 17 plus 5, we would need, so 1.5 times 17 plus 5, we would get 30.5 gallons. Or not gallons, ounces. And then if we did a 55-pound, that'd be y equals 1.5 times 55 plus 5. So 1.5 times 55 plus 5 we would have y equals 87.5 ounces. So again, with a line of fits, these are just good estimates depending on which points you use. Like here, we use the calculator, and on here, we use the points that they gave us, and our equations were slightly different, but they were close enough that our answers would be reasonable. So that is our lesson on scatter plots and lines of fits.